Good morning students, I am Dr. Pranika Bagin, Assistant Professor in Department of Civil Engineering of MVP Samadhas, KBT College of Engineering. In today's session, we are going to study the concept of flotation and buoyancy. When a body is immersed into the fluid, then some part of the body gets submerged into the liquid. So when the part of the body gets submerged into the liquid, some quantity of the waters get displaced. So weight of the displaced water is equals to the upward force acting on the body. So when the body is in the flotation condition, then body will try to move in the upward direction due to the upward thrust. And this upward thrust we call it as a buoyant force, or it is also called as the buoyancy. Now next term is the center of buoyancy. The center of buoyancy is nothing but it is the point at which the buoyant force is acting. Okay. Now the position of this center of buoyancy is equals to the center of gravity of the displaced water. When the body is in the immersed condition, so submerged part of that body is equals to the weight of the displaced water or displaced fluid, and Cg of the displaced water is nothing but the center of buoyancy. Now here this buoyant force is always acting in the vertical direction, vertically upward direction, and this buoyant force is equals to the weight of the fluid displaced by the body. Is the metacenter. When the body is in the flotation, then at that time the normal axis, over that normal axis, the center of gravity and the buoyant force is acting. But if you have given this small angular disturbance to that body, then body starts oscillating. So therefore here normal axis that means the normal axis gets shifted towards the tilted axis. And this tilted axis is nothing but the line of action of the force. So this normal axis and line of action of the force meets at a particular point, and that point we call it as a metacenter. Another way we can define the metacenter as the point about which body starts oscillating. That is also called as the metacenter. See the second diagram. In the second diagram, previously normal axis, along this normal axis B and G is acting. But if you have given the angular displacement to that body, then body starts oscillating. So therefore here that line of action of the force gets shifted from normal axis. So the new axis is get formed, that this line along which this FB is acting is called as the line of action of the force. So this normal axis and line of action of the force is meeting at a particular point, and that point we call it as a metacenter. Now from this metacenter we can define the another definition is nothing but the metacentric height. Metacentric height is nothing but it is the distance between the center of gravity and the metacenter. That means when it is the distance between the M metacenter and G, that is the center of gravity, is nothing but the metacentric height. Mathematically we can determine the metacentric height from the formula Gm is equals to I upon V minus Vg, where I is the second moment of area of the plan of the body at the water surface above the y-axis, and V is nothing but the volume of the submerged body, minus Vg, where Vg is the distance between the center of gravity and the point of buoyancy. Here B is the point of buoyancy and G is the center of gravity. So Vg should be subtracted from the I upon V. Next is the conditions of equilibrium for the floating bodies and the submerged bodies. The body may be submerged or floating is said to be stable when it regains its original position, when it is tilted by some angle. Now we will see what is the conditions of equilibrium for the submerged body. Now here in the diagram the balloon is there. Okay, that balloon is submerged into the air. Now when the body is in the submerged condition, the two forces are acting. The self weight of the body is acting at the Cg of the body, and second one is the buoyant force is acting. Cg is acting in the downward direction and buoyant force is acting in the upward direction. If you have given this small angular disturbance to that body in the clockwise direction, then body starts rotating to our bodies get tilted towards the right side or in the clockwise direction. But at the same time, when the angular disturbance is given to the body in the clockwise direction, this weight of the body is acting in the downward direction, buoyant force is acting in the upward direction. So this buoyant force and this weight of the body is creating the anti-clockwise couple. So clockwise disturbance and anti-clockwise couple is balances each other and body will regain its original position. So that is the condition for the stable equilibrium. In stable equilibrium, weight of the body is equals to the buoyant force, and second one is the when if you are given the small angular displacement in the clockwise direction, so weight of the body and the buoyant force is creates the anti-clockwise couple, and clockwise disturbance and anti-clockwise couple brings that body in the stable equilibrium, or it will regain its original position. And third condition for the stable equilibrium is B is above the G. So these are the three conditions of the stable equilibrium condition. Now in the second case, that is the unstable equilibrium condition. In unstable equilibrium condition, weight of the body is equals to buoyant force, but here the G is acting above the B. This is the second condition. Now in the third condition, that when if you are giving the angular displacement to that body, weight is acting in the downward direction, buoyant force is acting in the upward direction, so it is creating the clockwise couple. So clockwise disturbance and clockwise couples body cannot regain its original position, or it achieves the different position. These are the conditions for the unstable equilibrium. Third conditions of equilibrium for the submerged body is the neutral equilibrium. In case of the neutral equilibrium, that first condition is weight of the body is equals to the buoyant force, and second one is the B and G's are coincide. So these are the conditions for the neutral equilibrium condition. Now conditions of equilibrium for the floating body. In case of the floating bodies, the G and M is considered to identify the different conditions. Here in the first diagram, that body is in the floating condition. So along this neutral axis, this buoyant force is acting in the upward direction and weight of the body is acting in the downward direction. So next in the next case, if we are given the angular displacement to that body in the clockwise direction, then your normal axis gets shifted to the another axis. So along this line of action of this force, that B is get shifted towards the B1. So therefore, if we are given the angular displacement to that body, weight is acting in the downward direction, buoyant force is acting in the upward direction, and this weight and buoyant force is creating the anti-clockwise couple. So clockwise disturbance to that floating body and anti-clockwise couple brings that body in its original position. So this is the one of the condition. In case of this stability of the floating bodies, stable equilibrium condition, your M is above the B, as well as your weight of the body is equals to weight of the displaced water is equals to the buoyant force. So these are the conditions for the stable equilibrium condition. Now second one is for the unstable equilibrium condition. In case of the unstable equilibrium condition, the first condition is M is below this G. So therefore, when we have given the angular displacement to that body in the clockwise direction, weight is acting in the downward direction, buoyant force is acting in the upward direction, and it is creating the clockwise couple. So clockwise disturbance and clockwise couples does not bring the body in its equilibrium condition. So therefore, that is considered to be the unstable equilibrium conditions for the floating body. And third one is nothing but the neutral equilibrium condition. In case of the neutral equilibrium condition, M and the center of gravity coincides each other, and that is nothing but the conditions of the neutral equilibrium. Practical application of the flotation and buoyancy is generally used in the design of the aircrafts as well as in the designs of the ship models or the submarines. So by using this concept of the floating and buoyancy, that body can make the stable and the analysis is carried out. Thank you very much.